All right, hey guys, I just wanted to take a few minutes and talk about problem number 1. So this problem says you're building a new home and debating between installing solar or electric heating system. You're told that the installation cost for a solar system is $25,600 with an annual operating cost of $200. The installation price for electric is only $5,500, but the operating costs are $1,600 a year. So which will you decide? So obviously, there's going to be a ton of factors that go into this. How long are you going to be staying in the house? How much will maintenance be? Do you care enough about investing in something like solar, in an eco way, that kind of thing? But we can't control all of those. So really, let's just focus in on the amount of time. Because clearly the initial cost of solar is really big. If you only live in that house for a year, you're definitely not going to, at least financially, be making a good decision. But every year that you live in the house, right, once you pay that upfront cost, the solar is really only $200 a year versus the $1,600. So every year it's really a savings of $1,400. So the longer you live there, that cost is really just going to get closer and closer. So what you want to do, if we want to say, okay, well, at what point is it that turning point when solar financially becomes cheaper? So in order to do that, essentially what we need to do, first off, let's define some variables. So let's say T equals the number of years in the house, right? And then let's define a couple more variables. Let's say S is the total cost of solar in dollars. And then let's say E is the total cost of, electric in dollars. So once we have those variables, really what we can do is we can set up two different equations. So we can set up one equation that looks at the total cost of solar. So if we do that, we'd say S equals, well, we know the initial cost is $25,600. And every year that goes by, that cost is going to go up by $200. For electric, we can do something similar. We know that the upfront cost is $5,500, and then every year that cost is going up by $1,600. And so that break-even time, that break-even cost, break-even time, what we would want to do is we want to know when the cost of solar is going to be equal to the cost of electric. So essentially, it's kind of like setting this up. But in order to solve that, we actually need to use the other side of the equation. So we want to know when that side will have the same cost as this. And so if we solve for t, we will find the time at which those two costs are equal. So maybe I first subtract 200t from both sides. So I have 25,600 plus, not plus, equals 5,500 plus 1,400t. My next step would be to subtract 5,500 from both sides. And then I'll write that down here. I have 20,100 is going to equal 1,400t. If we take a look at that, that 20,100 is the difference in their installation costs. So that's how much more you're paying up front for solar, but the 1,400 is how much you're actually saving on solar each year. So when we divide both sides by 1,400, we're saying, okay, how many of those years, how many 1,400s do we need in order to make up that 20,100? When you solve that, you are going to get 14.36 equals T. So that's the number of years when the costs are going to be equal. So if you live there less than like 14 years or less, electric's going to be cheaper. And again, this is ignoring maintenance and any other factors going in. If you live there more than 14 years, then at that point, the solar is going to be the cheaper option.